Hello everyone. In this session we'll discuss Poisson distribution. Hello everyone. In this session we'll discuss Poisson distribution in the second part of discrete distribution. We'll see how we'll move from binomial distribution to Poisson distribution with an example. So basically this is a limiting case of binomial distribution when when the number of trials for binomial distribution increases or it becomes very high with the rate of success being very small, so that is when n tends to infinity and p tends to 0, with the mean value mu equal to np as a constant or a finite value. So NP will still remain a constant and a finite value, but the number of trials or n tends to infinity with the rate of success being very small. In that case, this binomial distribution starts giving error. So with error coming in binomial distribution, it is approximated and we can use the expression for Poisson distribution. The density function for Poisson distribution is given as, so in this case, the probability density for Poisson distribution is given by f of x is equal to e to the power of minus lambda to the power of x by x factorial, and this x can take non-negative integral values, so it can be 0, 1, 2, 3 and like that. For this expression, this Poisson distribution will have mean equal to n times of p, which is also equal to lambda, and sigma square, which is the standard deviation, will become lambda square. So mu is given as lambda and sigma square is given as lambda square. So let's see one example on this and try to understand how we have to implement. The question says, if the probability of a defective screw